So the next thing that we're going to look at is we're going to look at a rational function, finding the intervals of increase and decrease for it, because something kind of switches up here. So find the intervals of increase and decrease for f at x equals x plus 1 over x. Now, I'm just going to look at this function off the bat right here, and if I ever so quickly put this together as being a singular function right here, put it into my singular fraction, what we'd get is we'd get x over x plus 1 over x, sorry, x squared over x plus 1 over x, which would give me x squared plus 1 all over x. Now, if we look right here, well, when x equals 0, we're going to have a big, bad vertical asymptote. Don't worry about that. There is something important to bring up here, though. When we have that vertical asymptote when x equals 0, we can still have a switch from increasing to decreasing, or vice versa. So when we have a vertical asymptote, a switch can still occur at those points, and we need to take them into account. In fact, once we've taken the first derivative, we'll see that that actually still gives us a critical point, but again, we'll talk about that a bit later. So continuing on, what I'm going to do is I'm going to take the first derivative of this. So f prime at x is going to equal, well, either 1 minus 1 over x squared, or if I put that together, it's going to be x squared minus 1 all over x squared. So f prime at x equals x squared minus 1 all over x squared. Well, let's check out what are the points where the top equals 0. And the top equals 0 at plus or minus 1. What are the points where the bottom equals 0? The bottom equals 0 at 0. Because as I just said, we can switch at that vertical asymptote of 0. So the points that I'm going to be looking at to make my intervals or my critical numbers are going to be plus or minus 1, and they're going to be 0. Now, again, I get that the point 0 does not exist on the graph, but we're still going to list it as being a critical number to create our intervals. So I create my intervals. My intervals are going to be from 0, whoops, my intervals are going to be from negative infinity to negative 1, from negative 1 to 0, from 0 to positive 1, and from positive 1 to infinity. Now right here, when I'm listing off my factors of this graph, I could use x squared minus 1, or I could break it into its two parts, x plus 1, x minus 1. So I could have the x squared minus 1, or I could put it as x plus 1, x minus 1. Even though it's a bit longer, I'm going to put, well, x plus 1, x minus 1, and my last factor is x squared. Then again, we're looking at that f prime at x there. I take a number from negative infinity to negative 1, say negative 2. That would give me a negative there. That would give me a negative there. And x squared, well, it's always positive. So that would give me a positive right there. Negative times a positive gives me a positive. So that means I'm increasing on that interval. Say negative 0.5, that would give me a positive, that would give me a negative, again, always positive. So then I get a negative, so that would tell me that I'm decreasing. 0.5 gives me a positive, gives me a negative, that gives me a positive, so that means I'm negative and I'm decreasing again. And a number between 1 and infinity, let's go crazy and pick the number 200. 200 plus 1 is positive. That would give me a positive. That would give me a positive. So that would mean I have a positive, or rather, I'm increasing right there. So my intervals of increase are going to be from negative infinity to negative 1, and we're going to go from 1 to infinity. my intervals of decrease are going to be from -1 to 0 and from 0 to 1. As well, if I want to write this, I could write this with the union notation and just put the u in between. Now, one last important thing that we need to bring up right here is the fact you'll notice I did not include 0. And the reason why is because that 0 point doesn't exist. It's an asymptote, so we cannot include it in our answer. Oh, that was supposed to be no 0, not just no. No 0! Exclamation point. I hope you guys have enjoyed. Until next time.